Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about storage water heater. We already talked about tankless water heater, so let's talk about storage water heater. So why the heck do we want to store water? Well, reality is water takes a lot of energy. We discussed in past, Science Thursday. So reality is it's going to take a lot of kilowatt if you want to heat up a water to any temperature, as in like let's say 40 or 50 degrees Celsius, and it's going to take a lot of time or insanely high amount of kilowatt if you are trying to heat a water that is flowing. So fundamentally, storage allows you to solve both of those problems. And it's basically a form of what we classify as temporal compression, meaning like if you have heard about the news of we achieved fusion using lasers, how the heck that laser had that kind of power? It did not. It achieved a lot of power from the grid, which was high, but not that high. And then it temporarily compressed it, meaning that power it absorbed, let's say over a course of a second, it dumped that power in millionth of a second. So it gave a temporal compression. So energy went up. Same thing is here. Can a 500 watt heating element or 1 kilowatt heating element heat up 20 liters of water, 25 liters of water? Not really, especially in flowing. Hell no. But here's the deal. Give it a tank, give it time to hit it, and it's like, bro, I got you, fam. And if you have like let's say moderate use policy, as in like not everybody is like going YOLO, open taps and all that jazz, you will not even notice like how much energy these puppies are consuming because they are so efficient with it. It gives water time to heat up, and not to mention you will never have hot water to then directly cold water. You will have hot water, then moderate temperature water, and that's your sign to, hey, let's stop. So again, if you are draining too fast, that will not happen. But moderate drain, 1 or 2 taps, generally it will give you a warning. It's like, bro, like again, heating element will come on, but still it takes time. It takes time to heat up the water. So to enjoy temporal compression, size it properly and you're gonna have fun with it. And the water tanks are insulated, so water takes a lot of time to cool down. Now that many people complain is like this is the reason why they consume so much power. Well, true and false at the same time, because here's the these are generally used for large consumption, meaning can you have tankless water system most places? Yes. Can you do that on large buildings where you have, let's say, hotel, hospitals and restaurants and things where you're going to consume a lot of it? No. You're going to go bankrupt the moment all those tap system starts to come on, and God help you if all of them came online almost similar kind of time. The surge power that it will put on your grid would be brutal. So fundamentally, this allows us to deal with like a very large community, like 100 liter, 300 liter, 5,000 liter tanks. Those sort of things are possible in this. And that is only possible because you are using temporal compression. Otherwise, like it will require like 10 kilowatts of heat. Again, 10 kilowatt is still low compared to like, let's say, tankless heaters generally come to 5 to 8 kilowatt. And they can only handle some flow. And intake temperature is very low. Let's say intake temperature is 10 degrees Celsius. Yeah, good luck. This can give you hot water, as in like 70 degrees Celsius hot water. So that's why there are certain benefits of that. Insulated tanks, yes, they do leak energy, but if you are using them regularly, it's a very small fraction. And large buildings, again, you do not have other options there. Like for small option, I get it. But in large scenario, especially if you have low intake temperature, this is the only option you have. Then how the heck exactly we heat this puppy up? Well, we have one basic option, electrical heating elements. Now, this is outdated nowadays. Again, if you are low on cash, you're gonna buy this. But if you're high on cash, you're gonna buy heat pump options, meaning you're gonna buy a basically air conditioned unit that is running on reverse. Now, if you are in India, you have seen the plaque that is on there. Every electrical equipment that we are buying, 5-star plaques. Every air conditioner will have a bottom line that will say heat pump, yes or no. Now, I have an air conditioner running right now, and the reason it's air conditioner running in winter is simply because it's a heat pump. I'm running at a heat pump mode, so it's actually creating hot air here, and it's creating cool air outside. Now that may freak out. It's like, how the heck it's extracting heat from a cold place? Well, there is no cold in reality. All there is low heat or lot of heat. So that's why we have no negative kelvins. Basically, you go to absolute zero. There is no below absolute zero. So look from that point of view. And then we use refrigerant that boils at low temperature. For example, you want something that boils as, let's say, as low as minus 5 degrees Celsius. If it boils at that point of temperature, it's extracting the heat. And outside air is like a very large thermal reservoir. Temperature wise, it's not that hot, but in terms of oomph, in terms of joules it is more than enough. It's almost like an infinite reservoir. So you can drain a lot of power from it. And inside you compress that puppy. That's why we have compressor. And then you can heat up water or heat up a room. Like this room is quite cozy because this is ground floor. It gets cold. Without this air conditioner, it would be brutal here. So Heat pumps are using that. Now, the primary benefit of that is that it exceeds 100% because it's not generating the heat that you're consuming. Heating something is 100% efficient. That's good. Here's the deal. What is better than 100% is exceeding 100%. So once you have an air conditioning unit, you can achieve idealistic condition 4 COP. What does that mean? That simply means if you're this puppy or small units are consuming 600 watts of electrical power on the compressor, you can get 2.4 kilowatts of heating. Let that sink in. 600 watt in and you got hot water of equivalent of 2.4 kilowatt. That is significant. Like that is significant. And in some places people do basically cohabitation of these sort of thing. Meaning, let's say you are dealing with a restaurant that has a very active kitchen, very hot kitchen. They'll put this puppy there or close to it. And benefit of that, the kitchen needs to be cooled. This is like, I'm going to cool you. I'm going to extract all your heat, dump it into water. The COP exceeds 4 or 5. Because again, these COPs are generally measured on worst case scenario, like outdoor temperature, ambient temperature is very low. But if ambient temperature is hot, this is like, bro, free lunch. Or if some scenarios, let's say you are dealing with a hotel, it has a like, let's say server rack, which is having a lot of security camera, Wi-Fi, internet, all the jazz. That's hot. Now, you shut down the AC that's there or made that AC run very rarely if it detects temperature goes too high, and then you put there. It takes all that heat from server room, dumps it into your water, free hot water. In hospitals, many times the hospitals could have freezers that are dumping a lot of heat extracted from medicine to keep it cold and dumping it outside. Put it next to this. It's like, I will eat all your heat for free, give you free hot water, and even the compressor that is working to cool down that system, even that will enjoy it. So COP will become better in all scenarios. So 4 COP is not like, whoa, never achieved. And here's the deal, even if it's only 2 COP, you only get 2, you put 600 watt electrical in, you got 1200 watt out. That's not a bad deal. So fundamentally, at large scale installations, meaning if you are thinking about installing something that is more than 100 liters of storage capacity, not buying this means you hate money, especially if you are in a scenario where you're going to use this water a lot. For sometimes you may be like, only once in a while people use it. So electric water heater, because be mindful, these things are expensive, of course. You are paying for this and a whole air conditioner unit. And these are not as simple as like, just joinking a heating element. So the coil has to be wrapped around the tank. It's a bit more involved, tedious, but it does work. And be mindful, all these tanks do have backup heaters, or sometimes it's like the ambient temperature is not allowing it to run very efficiently. So it may be, rather than like stressing the compressor, you may be like, hey, at this point in time, it just makes more sense to use the thermal electrical element. Or if you are shutting them down for maintenance, you will not have downtime on your hot water system, but you will have downtime on your bank balance if that is done. Again, desirable. So at large scale, flat out heat pumps make sense. And is there anything that comes close to this efficiency? No, because this crosses 100% efficient. So even if you have, to give you a context, how big this deal is, you take the LPG that comes into your home, or methane that comes to your home in a gas pipeline, take that methane and extract calculate all the value. Here's deal. This is still better. How the heck? Why? Well, gas to electrical energy efficiency is around 50% on large power plant. Then your transmission losses, then it comes to you. So if you are crossing COP of 3, which you can easily do, at that point in time, this is still better. That's why there is no point. If you are consuming a lot of water, use this flat out. If you're consuming a lot of hot water, if you're in a big building, if you're in a scenario where you have to consume a lot of electrical energy for it, or even a gas lot of it, just buy this flat out. The high capital cost pays itself very quickly as 5 years or 3 years in sometimes. So these are the methods, especially if you have a cohabitation of this puppy. Like, put this puppy somewhere where you have waste heat, and this puppy will thank you. So let's understand the mathematics of it. Well, the mathematics is here simple. Let's say you go to a shop, and shop is like, hey, for 1.5 kilowatt unit, we have these many capacity options. We have 5 liters, we have 10 liters, we have 15 liters, 20 liters, 25 liters. And if you go above 25, you will get like, let's say 3 kilowatt thermal elements. So here's the, buy the biggest one, flat out. Why? Well, surface to volume ratio is the key. People, yeah, it has to heat up a lot of water, but here's the deal, that water is not going to disappear, nor that water is going to cool down instantaneously. And the larger you make it, the surface to volume ratio changes, meaning how many liters, is touching basically what kind of square centimeter area, that changes, ratio changes. The bigger the tank, the less heat loss you will have to ambient, meaning this small tank, if you have, let's say 50 of these small tanks versus 50 size larger tank, the larger tank will lose fundamentally less heat. To give you a context, if you make a rocket tank big enough, like let's say Saturn V, you can actually have a scenario where you can just put liquid oxygen there. It will take very long to boil off. You can just top it off and just launch the rocket. You do not even need to put insulation if the tank is large enough. That's why the surface to volume ratio matters, not the volume nor the surface, the ratio among them. So small ones, they look cheap, they look fancy, they look cute, but generally they are bad for your bank balance. And yes, people will say, oh, it takes a longer time to heat the water up. But here's the deal. You are taking the advantage of temporal compression. And in some scenarios where you have the luxury of, let's say, different electrical rates at night, you can just turn them on at night, controlled by smart thermostats. Or in case of India, where you have some places have like really bad power cuts happen, we can turn this on for, well, 24/7. It will only come online when like it detects let's say electricity and there is cold water. And because it is such a large tank, it will take very long time to cool down. So flat out, bigger tank is better. So if you have a hotel or restaurant where you're seeing, not restaurant, hotel or hospitals where you're seeing a lot of other options than this, like small units, that means it was retrofitted. If you are mindful, if you are doing the maths, you will always put bigger tanks. Bigger tanks are your friend. And low power heaters, because of these things, a low power heater can heat a lot amount of power, water over time, but you have to be mindful. You have to give it time. Now, if you are in a scenario where let's say all your taps are running 24/7, yeah, nothing is going to help you at that point in time. But if you have normal, realistic use cases, let's say 4 hours of continuous water draw and then chill for 20 hours, this is like, I got your back. I will save you money. I'll save you stress. Everything will be fine. Rooftop solar, because these things are so, I told you, like 600 watt of input, you get 2 kilowatt output. This can run on solar rooftop, meaning if you have running on like off-grid system, these can actually work. So mathematics are simple. Buy the biggest one and understand the temporal compression aspect. And if you are in saying, no, it's not working, add a bigger tank or add 2 of those tanks, because at some point it becomes more cheaper to just add 2 of them. Even though mathematically it would be better to have one larger tank, it's just that transport becomes ludicrous. So they are like, just put 2 of them. Then we come to the sad aspect of, basically this sort of system. If you have a large piping, which you will have in a, let's say, a hospital or restaurant or any place, you will have large amount of piping, you will have cool down of the piping itself. And piping has very high surface area, very little volume. So consequently, you'll always have cold water and you have to wait few seconds, depending on the distance from the hot source to your tap. It could like take few seconds to few minutes before you get, and that's not acceptable for many people. In some scenarios, again, I get it. If I'm in a hospital, I want like hot to hot. So how do you solve that? And that's how the tankless water heater became a craze. But here's it, there is a solution in storage tank also, which call recirculating pump. Now what it does is basically, ideally the first thing you will have is insulated pipe that will reduce your loss right on the source, and then you will have new instrument, basically installations that you are building, like the new building, you will have a return hotline, recirculation lines. Now this does require, while you are building the building, you have to build that puppy in right there, and many new houses have that. And that benefit of that is you get the advantage of everything. You get the quick water flow of basically a tankless system, and you get energy efficiency of thermal pumps, heat pumps basically, and it's circulating. There is a small pump like this, and these are very low wattage pump, basically 200 watt or sometimes 100 watts pump, very low power. And here's the deal, they are running on timer, they are not running continuously. You can run them continuously. Many times in hotels they do run it continuously, but in normal home scenario they will have like timer. It's like, hey, in early morning from let's say 4 a.m. to let's say by the time everybody leaves your house, let's say by 12, run this pump. It will keep circulating the water, so the moment you open the tap you will get hot water. Or if you are unlucky, let's say your household is like normal household, hot water pipe, cold water pipe, there is no return pipe, no problem. You can just put this sort of valve. Now the moment the motor will turn on, this valve will open and this will force water into the cold sink, and that will go to your geyser. Because again, like in case of India, we have large rooftop tanks, so that has higher pressure. So of course water is not going to go there, it's going to go place where there is void. The void would be in the geyser, water heater, and the water circulates itself. Benefit, you open the tap, voila, hot water. You no longer have to be like, I have to burn 5 kilowatts. Like I was shocked, like the amount of electrical energies those things consume, and people just like, yeah, this is a 5 kilowatt unit, this is very good. I'm like, 5 kilowatt, dude, my whole household load is not 5 kilowatts. And some's like 8 kilowatt, and you will never feel. It's like, that's a lot of drain. And good luck doing that on solar or in Germany where you have like very high heat costs. That's why this sort of system is the ultimate solution. If you have return line, that's awesome. Like nobody would even notice it, and your bank balance will also, because this thing, if once you figured it out, many people have figured out how to run them on Alexa and all that jazz. So it detects things, then it's like, okay, temperature is dropping, okay, then I'll circulate it more. Then temperature is not dropping, it's like, I'm not gonna circulate it. So recirculation pumps allows you to have easy and instant hot water for use. It solves all the problem, gives you advantage of heat pump system, and large buildings can use this. This is how all 5-star hotels can have like hot water. Because be mindful, if they had did that hot water thing under every sink, yeah, their transformer will be like, bro, I'm out. So recirculation pump is the easiest way to get best of both worlds. So do not let anybody tell you it's like, oh, you can't have, hot water, instant hot water. You can, it's just tedious. Or like not even tedious when you're just, all you have to add is just this valve and this tiny motor. Now let's come to the ugly part of it, maintenance. Now here's the deal. There is nothing fundamentally in a water heater system, especially electrical one, that requires, basically that has a limited lifespan. There is inherently everything that in there is there that should last forever, basically, fundamentally. But if you have the biggest enemy of everything, that is hard water, of course it's not going to last very long. And then if you have no maintenance, these things are terminal, meaning why did your water tank went poof? Because you did not do maintenance on it. So how do you do maintain on it? Well, in India, we used to have like soft water. Now we have hard water, because again, a lot of boring, a lot of water extraction, water table went down. We are getting way too much mineral now. So even like this was a common thing in Western worlds, not common in India. We did not had anode rod in our water geysers. Nowadays, they are there. Even on small tanks, I'm talking like 5-liter tanks, they have anode rod, because it's like, yeah, it's better to corrode this puppy because it's designed to be replaced. You just keep replacing them, your tank remain intact. And the large units, they had a bad design in there, that shaft, like this thing was like a freaking 4 foot long. So they have learned from that mistake, and it's like they're creating this nunchuck style where you can fold it and then put it there, because if you do not have roof clearance, this will be far more easier. So that's the first thing, change your anode rod frequently. And if you are open it up generally they say, please open up your anode rod in the year 1, because if you have very hard water, this will be corroding exponentially faster. Generally they say 4 or 5 years, but here's the deal, what if you have extremely hard water? That time you have to replace them quickly. So that's the first line of defense. Second line of defense, flush the sediments down here, because you are cooking the water basically. So you're going to have sediments, and sediments could be in kilograms, especially in few years old models. Not models, I think like few old running system. It could be pile up like kilograms of it. That's why all large tank system, they have a flushing system. So you're supposed to flush them out yearly, so you do not have sediment. Because be mindful, this is what kills your heater. This is what coats the basically heating elements, and it reduces efficiency, because your heating element is like, dude, why the heck there is a blanket, and you want paying electricity for the basically water, not electricity for the heating of a calcium cover, basically this gunk. You are paying money to heat up the gunk. It's inefficient. So you may be like, hey, why the heck my water heaters are taking so long to come hot water, and it takes so much electrical bill? Yeah, you may have sedimental issue. So fundamentally, if you maintain these two things, basically replace your anode rod, flush these things as quickly as possible yearly, you're gonna have a very good time and very long lifespan. And nowadays people are going away from steel. Sometimes they are going flat out of plastic tubes, tubs, because again, inherently they will last even longer. And sometimes they're going to titanium tanks with glass insulation, not insulation, it's like glass enamel coating, so to say. At that point in time, that tank is fundamentally indestructible, even in very harsh water. So fundamentally, you can have a water tank that lasts very long time. So do not be like, oh, water tanks don't last. It's like you are not maintaining it. And given the fact that heat pump systems make it so energy efficient, you have to do it unless you hate money, especially if you have very high water consumption. If you have very little consumption, I get it, because heat pump systems is like you are adding a expensive water pump plus a heat pump. Yeah, it's expensive, but I get it. So in large system, you have to use heat pump, but heat pump has the same maintenance cycle as normal air condition. Actually, it has less fan units, because the evaporator side has the same system. Evaporator system has the fan, the condenser does not have the fan, because again, the heat is dumping into water rather than air. So that side is, it has like less component compared to a normal air to air heat pump. So fundamentally, less maintenance there also. So if you maintain it properly, like back in the days when people were very serious about their component, people used to actually pull out their heating element and actually wash it in vinegar, and then voila. Like if you do that to your heating elements, it can last for decades. Flush it long enough, quickly enough, yearly enough, and then change the anode rod. These things can easily last 20 years, 30 years, 50 years. And yes, there are people who have that. The reason was like just maintenance. If you have good maintenance habit, these things will last forever. You don't have good maintenance, buy whatever the heck you want to buy, it will not last long. So maintenance is key. So this was my presentation on storage water tank systems, water heating systems. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.